And we got number 7. We see a graph. We have hopefully in our notes somewhere. First thing is to look at what graph it is. It's velocity versus time. Okay, and it tells us that up here. What's the average velocity from 0 to 50 seconds? So be careful. We're looking at this time right here. Okay, we have an equation. Average velocity is change in position over change in time, and that's the area over the delta time. So we are looking for this area right here up to 50 seconds. So a real common mistake would be to give us the whole area, but the delta S from 0 to 50 is just that area right there. So let's break this into 2 parts. Let's call this delta S1 and up to there, because that's easy, and delta S2 up to there. Alright, so delta S1. It's always good to get the right color. It's always good to label things so we can follow your work. Delta S1 is going to be 29 meters per second times 30 seconds. Got my calculator over here. There we go. Get out of that. 29 times 30. 870. 870 meters. Delta S2 is the area of a trapezoid. Hopefully you have that in your notes. It's 1/2 the average heights. 29. We don't know that velocity value right there. Alright, so we're going to have to calculate that. If you happen to notice that it's going from 29 down to 0 and we're halfway through, you can see that it's just going to be 29 over 2. Okay, if it were a little more complicated than that, you would actually have to sort of work with similar triangles. So to work with similar triangles, let's write that out, since we'd have this triangle, this in green, this triangle right there, and then the larger triangle right there. Would be another way of doing it. So you could say the height of the larger triangle, 29, to its base, which is 70 minus 30, is the same as h over 70 minus 50. Okay, so 70 minus 50 is 20, 70 minus 30 is 40. Take the 20 over the side, that's where we get the 1/2. Alright, so the h is half of 29, 14.5. Alright, so that was a common mistake on a lot of people. 14.5. Let's not get carried away here. It's 1/2. Where's my eraser? (29) plus 14.5 meters per second. Alright, so there's my average height, and I'm multiplying by the base, which is this 50 minus 30, or 20 seconds. Alright, so 0.5 times 29 plus 14.5 times 20. 435. So my total delta S is 870 plus 435, 12, 1305. Let's make sure that's right. Plus 870, 1305, and units of meters. 3 significant digits is that. A little more involved in having to find that intermediate number right there. Alright, that was our delta S, and that's not my final answer, so I messed up there, and I need to find an eraser again. Here we go. So that is delta S. My velocity average was this equation. Okay, so velocity average is going to be 1305 meters over 50 seconds. 26.1 meters per second. That's my final answer. So a good hint on the test would always be to double check what's being asked for and double check that you have units. Alright, EF-157 class, field trip to the moon, 1/6 gravity of Earth. They ran out of fuel when they were 911 meters above the moon's surface and up speed of 72.1. How much time they have left before they crash back to the moon's surface? So a lot of words here. The key is to find the important things. So there's upward speed. They're at 911 meters. We want to find how much time. And let's see, gravity's 1/6 of Earth. So let's draw a quick picture here. Here's the surface. We'll take positive as up. We're 911 meters above. Okay, we have an upward velocity, 72.1 meters per second. Okay, we want to find the time. So what's happening here is it's going to continue to go up and then come back down. You do not have to find this in 2 steps. You can just use your constant acceleration equations and work it through from point 1 to point 2. Alright, so let's write down what we know. We know S1, 911, V1, 72.1. We know S2. If we set our origin down here, that's going to be 0. And we know acceleration. Let's fix that. Minus 9.81 meters per second divided by 6. That's 1.635. Alright, we need a constant acceleration equation that has time in it, that does not have V2 in it. Don't care about how fast we hit. So that would be our S2 equals S1, V1t, AT squared. S2 is 0. S1's 911. V1, 72.1. 1/2 minus 1.635. t squared. Okay, again, your favorite, looks like I forgot a t in here. Favorite way of solving quadratic? Mine is the solver. Math 0, up arrow, clear, and just enter the equation in. 911 plus 72.1 x. I'll use the minus sign right there, 0.5 times 1.635 x squared. Alright, I expect this to take 911 meters. We're going upwards maybe, I don't know, 20 seconds. We'll guess that. Always fun to guess. Okay, I got a solution that's negative. So that says that probably wasn't a very good guess. I'm going to guess again with a much bigger number. Let's go 200 seconds. And that gives me an answer of 99.4. So, ignore air resistance, 99.4 seconds to hit the ground.